I have a mixture of two topics. It's Apertis and ELISA. I originally got the approach to talk about Apertis, and I said that I'm also a member of the ELISA project of Linux Foundation, and it seems to be a certain interest maybe from automotive. For this, starting who am I recently joined Bosch. I've been 14 years with a small daughter company of Bosch. That's also how I found to ELISA, because we were in the past active in Genevi, Covisa, AGL, Linaro. So it's typically where they put the company in because it was smaller and much better to work there, less hurdles from bureaucracy and so on. And I recently joined as Technical Business Development Manager, long name, but you can shorten it to BD, so TBD Manager. And I'm here to talk about Apertis. I also will talk shortly about Bliss, that the kind of umbrella project also where I'm mainly sorted in, and then a large bunch about ELISA. So as I have the sponsor of the project, there is the Bliss, which we call Bosch Linux IoT Service System. The principal idea behind is that we have so many different business units in Bosch, and we pull a few of them together and just try to enable their communication, because in the end even an automotive device is not much more than an IoT system, because everything gets connected, and therefore automotive parts are IoT. And there was a logical idea to then just start with Apertis, because Apertis was already existing like 5-6 years in Bosch. For all who haven't been in touch with Apertis so far, it's a free and open source project. Actually, it's mainly created by Collabora and Bosch. They're the main drivers of this activity, but they put everything to the open. So that you have the repos on it, you can see how the infrastructure looks like. And we selected Debian due to the stable packaging mechanisms behind for the long-term support. So with modularity in mind, that you can manage product lines and also have a better view on security. And here it's coming from automotive, but it's not limited to this. So you could, I put the e-bike in there. Actually, it's not an Apertis Linux in there. I have to be fair here. It's an own derivative on the i.MX6. It could also be in the lawnmower or household equipment. If you have whiteware where you have suddenly connected dishwasher or whatever it comes in. And yeah, that's where the system comes from. So it's a wide range of use. Fair to mention, we're currently also looking for additional partners who would like to join the Apertis, and if we find a range of 5 to 6 supportive members in their companies, we'll get to open most likely a Linux Foundation project out of it. That's still our goal. Let's see how far we get there. Then, what's a little bit more in the Apertis compared to maybe what you see as standard distro, we saw that a lot of Bosch units start from scratch. So they have an idea, they want to get something connected, and then they just go to a silicon vendor and they get their Yocto BSP, and then they start building up, they grab it, maybe Jenkins when they still have one or whatever infrastructure they're in, and at some point of time they see, oh, we need to build a real product out of it. And that's where we said, start with something, let's try to unify some elements. So we had an infrastructure where you can see that we have real Debian maintained software, but the packages are often not enough, so we get another sources in there. There's something also what we call these vendor-specific PSD parts, so processor-specific drivers. GPU is a typical example where you don't have full control. And then you pack the things together, create the binaries as you need, and then typically what you would do is you would have a Debian system, you run it natively, and then you have a package manager, you get the packages you like. For this, we start with this image creator, which basically collects what you need as packages for an image and then creates your image out of it. Idea is also that on the long run with over-the-air update, you don't want to have a package manager most likely on your embedded device. You want to be able to directly deploy things. Right. Lava we use as testing infrastructure, the fabricator for having interactions as project management, and we're currently also looking how to more modularize this so that you don't need to use all the elements of it. Well, yeah, and this, I said this is part of the Bliss project, and is that the pointer here, right? Doesn't work. Don't matter. So we have certain contribution which we're doing, so Apertis is one of the project, but as we see an IoT system is so much more. We also go and work with the Eclipse Foundation. For example, in the Eclipse Canto, we look in the software-defined vehicle. We're also contributing as Bosch side to Sophie, so to have there also where container technologies come in, and so on. We're currently discussing to join the civil infrastructure platform project because they have the nice ideas about the long-term support. They maybe not fully comply with our idea of going with a tip of the kernel for a long time, but we need to find places, and as license compliance come in, also discussing with the SPDX guys. As we are not the open source community, basically Bosch is still, when you think about, mainly a hardware provider, so we need a long way to bring people more to software. So we took collaboration with CodeThink, Collabra, the OSADL in Germany, quite active, and also Linux Foundation, so we get some guidance, some support from their side. And we go out to Bosch internal revenues like the Bosch Connected World or Bosch Conference on System, but also to ELISA Foundation workshops, to the Open Source Summit. We give a talk there in North America in June, and that's where we go. And then in this way, we hope that we can enable the open source software stacks in more Bosch units. And also, in my role, I try to get more people involved, that they are willing to speak, that are open to discuss, and just see what's in the world outside of an intellectual property NDA automotive branded company. So it's a longer way on this. And one thing which I would like to get in is now the ELISA part, because we try to join there and there was an interest in this. I'll start with a short overview and strategy overall. So ELISA itself is about enabling Linux in safety critical application. That's what ELISA is. For the automotive guys, funny part, if you read it backwards, it's ASIL-E, so which is typically the safety integrity level, which just goes up to D. And we would like to make it easier for companies to build and certify Linux-based safety critical systems. It's not that we will reach the point. What is important for this is that we see that we do an assessment whether the system is safe, and therefore we need to understand the system in detail. And also the role of Linux within the system, because the system can be much more. You can say there's a container architecture virtualization, there's an RTOS, certain ecosystem, how to build a system, then you bring it into devices, you have sensor interaction, so you need to really understand what is the system context. And one element of this could be, if we are not making it directly safe, which is not our claim, we look into components and features of such a system. We say what is safety relevant, what is less safety relevant, and identify also gaps. Gaps can also mean in the field of processes, because Linux was not developed as a system for safety. And we put a lot of these things together in our mission statement. There's a white paper out there, which you can simply read. It's on the ELISA tag main web page, so just go on elisa.tag and you will most likely find the link directly. It gives a lot more words on the strategy, which I'm just explaining, and how things go. But it's important that even if we try to bring processes, tools, get an understanding of things together, there's limits which ELISA cannot do, and we cannot engineer the user system to be safe, right? You cannot have the Linux distribution as such for safe. It's use case dependent. There are elements in there, you will later on use it, and it's not that we have the target to make a safe Linux. Important. We want to enable people to build applications based on Linux. And we also can just give guidelines, but it's not possible that all these things are really applied, and it's all in the responsibility later on further. So it's more a path forward and a really open collaboration space. Jump over this one. Here you find at least the term Linux kernel, so you see a lot of work is more in the kernel area currently. We're not on the wider system scope, but whatever we do should go out later on in deliverables. And we have for this two use case work groups, the automotive and the medical devices. I tell a little bit more about the automotive then. Next slides. And what's also their safety architecture. They basically look into kernel elements, kernel functionality, how are kernel subsystems used, analyze how a Watchdog driver looks like, because Watchdog is a very nice thing which gives benefit in safety systems. And we have the open source engineering process, which is wonderful because Linux was never developed with the safety integrity standard in mind. And they really look into how does a typical reference process for safety systems look like, what is the kernel community doing, where can we enhance documentation, and this is really like bridging the gaps on it. And out of this open source engineering process group, there was also Linux features there. This is a subgroup which helps to give elements for kernel configuration, looking into how a Linux kernel can look like on a feature set. So which features would you like to switch on, which features would you like to switch off, which can be enhanced, where are security mechanisms which can help to enable then a Linux also for safety. So these are in there. And the last part is it's also a little bit for testing. We have a tool investigation and code improvement work group. I would say this is the work group which provides currently the most to the kernel development. So what they do, they are doing fuzzing with the syscaler, they have code checker on, they read reports, they start preparing patches, and it's a very small group, but I would say currently they have the largest impact to the actual kernel development. The work they're doing is public, so you can read it, you can log into code checker and to syscaler to see the latest results. Guess the password is guessed and the user is guessed, so you have just read access. It's also written there somewhere, I guess, and it's just to see what's going on there. Here, I already talked about the Linux feature, the LFSCG group. They do really the deep dive into specific kernel features. As said, they look into memory management, kernel configuration, this kind of thing. Try to understand how stack management works, and this is very important. They interact also with then the other work groups from safety architecture and the open source engineering process, and a lot of work. So ELISA is heavily influenced also by Red Hat. So, but this is in there. Right, then open source engineering process already mentioned. So they don't spend too much on this. The very supportive work group for us, where also Red Hat is in lead. Currently, there's the software architecture work group. The software architecture work group currently does a lot of analysis of the Watchdog timer. So they see how can we make use of a software watchdog, because in our current automotive design, we take an external watchdog. This makes our life much easier, better argumentation. And another thing which also comes in is another element next to the watchdog analysis. They also do runtime verification, so that they also try to figure out how can a system be tested, what data do we get from runtime, because there are a lot of concerns on running Linux as such for safety application. Yeah. Short view on medical devices. I'd like to stress this because it's very interesting. Typically when you think about functional safety, you think about standards, a lot of compliance thing you need to do, and what happened on these open APS. So is glucose monitor system, and this is a community project where some people just attached a Raspberry Pi with a little bit of equipment to it. You have a Python script running on it, a few hundred lines of code, and that's monitoring their glucose level with an insulin pump, and it's controlled like this. And you can see how the real work improved, and what the intention of this is, why we take it up, is to really get a system understanding to see how is the kernel involved, is there something which could go wrong. So we want to support the safety argumentation here, and for this we use system theoretic process analysis, STPA. There's a nice handbook on it at MIT, so if you Google for STPA you will easily find it. And here's basically the idea to ignore standards or so, but just make sure that there's a good system understanding and maybe improve things. Right, now finally, automotive. We have a bunch of automotive members in there. So just to mention, sorry I didn't put Red Hat in here. I know they make a lot of effort in automotive, but I don't see them as a traditional tier 1 for it yet. We see a lot of people from Asia participating in there. BMW and Toyota are premium sponsors. That's why their icons are a little larger, just to get an overview. And what we try to do within the automotive work group is that we look for conditions, prerequisites for automotive sector, how to integrate Linux into the safety critical systems. It's a large volume market, so therefore it's a good chance to get Linux in, and there's also already Linux placed for infotainment devices, for example. So for this, it's a good idea. And yeah, we selected the telltale use case, which you can see as like the gear indicator, check engine light, and so on. Traditionally, there was LEDs in the past. Nowadays, it's all coming into an instrument cluster, a digital one, and it's a fairly simple use case. That's quite nice. If I show a picture, a lot of people can understand it. We don't have to mess up with too much real-time requirement on this because we have like few hundred milliseconds when something can be displayed. It's important that it's displayed, but it's not like, oh, a light goes on, I just turn right and put my car on the side because I just saw like a check engine, right? You would typically write, oh, what's this sign? Oh, I haven't set it. Oh, and when I come home, I need to read what it is. So we have relaxed timings on this. It's kind of interesting for EMs. Also, they all come in, why don't you do autonomous driving? But it's something where we work on. The drawback of this use case, also to mention, I guess I have no slide from it, it's in the end, all the work we're doing currently is not really making use of Linux features. So you can just simply take any other OS on it. So there's nothing where we really get into, we have the external Watchdog in there, so just to delimit our scope. And but I also see it as a benefit because it enables interactions with others. Right. And yeah, as we are in automotive, the first words we heard were IP and NDA. So we tried to base the demo on an SoC. And we said, oh, there's a nice display content checker. Can we get the spec for it? Oh, will you sign the NDA? I said, no. Then like, oh, can we get a little bit more on this? Well, that's IP. Can we get this as source? No, that's binary. And then we said, what do? We end up with a QEMU-based demo. So there's no hardware in there, of course. The Watchdog is not externally hardware Watchdog, but for setting up a model, it's fairly enough. And yeah, what you can basically see is just the cluster that's from AGL. They had it in mind already, so they could just use their Yocto layer and add our little components in it. We have the documentation also on GitHub for the automotive workgroup. And I have a demo video which I will skip due to the timing reason. But you basically see that we hook in with a little small component, which is also not written with safety in mind. It's just to understand the architecture, the elements which are in there in the kernel, and that everybody get picked up. And we just monitor an area of interest if something is displayed. If you hover over a mouse, for example, in this layer, then it will detect that the telltale is not properly rendered, sends a signal, and the system gets in safe state and get rebooted. So that's the thing in there. Right. And yeah, you heard the SDPA before. The SDPA is used in the tooling group, or in the open source process. They actually did some way of using this analysis to certify and qualify a tool around the analysis for ASLD, and it's also in the medical devices. Why is this such a nice thing? So you can draw these fancy diagrams with your tool of choice. So SDPA is just the methodology, because this was drawn, I don't know, if we start with plant UML, we get to Papyrus, and we move forward to see how we handle all the complexity. I guess this one was drawn in with something else. Yeah, the good thing here is you can start with something. So you start with a single box, and you start this is where the highest level one, where you just say, here's system, what's your input, what's your output, what's your control structure, how do things interact. And then we put this thing further and say, what is something part in our system? That's everything which is not gray. We said the gray parts are out of our control, out of system. They provide input. And you can then start discussing what could happen. And you look basically at each node. First you're saying, what could go wrong in this system part? What could later on, what could happen from the request handler to the telltale checking? Which paths do we need to consider? And if you don't know an area yet, you just leave this box on this level, and you can granularity go on deeper levels. And this is very nice from a refinement method. And automotive often comes with like HARA analysis, and they have these large Excel tables which nobody can understand anymore. But this could be a good addition, substitution on it, depending how brave you are. And yeah, what we're currently doing is to work further on this analysis. We wouldn't have to do this if we got all the specs from previous projects, but we don't get them. We also figured out that the kernel as it comes is quite large. There are certain elements in there which we don't need, so we also trimmed down the kernel config. I guess we don't need the CUPS printing system in there unless we want to print an error message maybe. And yeah, what we also figured out, whenever new people join, we need to improve our GitHub documentation. That is really, I think we are in a good way that we have a step-by-step instruction. We even explain how to overcome the GitHub sign-off issues, which you may end up with, where it says all the DCO checks failed. So we put it on this level. And another thing which comes up for the next part is also to update. We need to work further on this, get down to the next level. The medical devices are ahead of us. We also get in touch with them so that results look similar between all the deliverables within ELISA. And we also need to update to the latest AGL version. That's something going on. And the last part I marked out here. That's also why I'm here today a little bit. Besides the nice topics yesterday and today, we need to outreach a little bit further, because we really see that we need more input from automotive. We are driving this use case. It's not the most attractive one, so it's a lot of motivation which we have to give. And yeah, this is something where I had talk also at automotive technologies conference. Yesterday, I guess it was virtual, so it was very nice in parallel to this one. Yes, this is something where we're looking for, and we also need contributing partners. You saw the Asian guys win there, but it's very hard to get US involved and Asia, so we have double calls, aligning, and so on. This is something which need to improve a little bit, where we need to find more. And for this, I have some resource links in there with currently 150 members actually subscribing to the mailing list. In the actual work group, I see regular attendance maybe of 10. So, and this is all more our side topic, as so often it is in open source. So it really depends on this time we find during weeks. Right. This was the main end of it. I thought I'd keep the content short so that there's room for questions. Yesterday evening when I started to talk about ELISA, then was basically that there was already a lot of questions during social when I had it during lunch. Also, therefore, yeah, reach out to me, and if you have already questions now, if you're interested in joining the Apertis or ELISA, for example, would be more than interested. Right.